Welcome to Samik Teach. So today basically we will discuss about the biomaterials. So as the name suggests, biomaterials. So the materials which are used as the biological used in the biological body or used as implant for biological system. So those are some properties and definition also. So the definition of biomaterials are getting changed day by day. From post to present, if we are going through the definition one by one, so then we will come to know that how the evaluation of biomaterials taking place. So student, first come to the definition which is given by the Smithsonian University Advisory Board for Biomaterials. A systematically and pharmacologically inert substance. So basically, this is inert in nature. That means it will subjected to not subjected to react with body or host. So those so previously biomaterials are basically this kind of biomaterials means they are not react with our host body. They are just placed as a support with the failure organ or tissue. Now comes to the little bit upward upward definition of biomaterials or upgraded definition of biomaterials, that a biomaterials is any substance other than drug obviously, or the combination of substance such as any kind of composite materials, maybe synthetic or natural. So from natural origin we can get like any kind of protein, collagens, so these kind of things, and synthetic those we have synthesized in our lab like hydroxyapatite, bioglass, this kind of biomaterials. So which can be used for any periodic time. So those are used for some periodic time, not a continuous process but some period of time, okay, like 1 year, 2 years, 6 months, 3 months, so this kind of thing. And the implant or the biomaterial used used in this as per this definition are basically used as a are taking part of a system which treat and augments or replace any tissue, organ or function of a body as per the definition by Williams. But after 10 years, Williams also defined it more logical way, that a biomaterials which intend to interface. So previously it not interface with the biological system, but now he is giving the definition as that it will interface with our biological system to evaluate, treat, augments and replace any tissue, organs and function of the body. So basically they are bioactive in nature. Bioactive in nature. So those have some properties like bioresorption and bioabsorption. So now comes to the part how we are basically define biomaterials in the respect to the reaction with the host body. So first comes to the bio-inert biomaterials. So as per the first definition, we get this kind of biomaterials which has minimum interaction with its surrounding tissue. Generally, a fibrous capsule might form around the bioinert implant, and its biofunctionality relies on the tissue regeneration through the implant. Basic example of this kind of biomaterials are stainless steel, titanium, aluminum, zirconium, and ultra-high molecular weight polyethylene. Next comes to the bioactive biomaterials. This is the recent trends or recent as per recent definition of the biomaterials. So today's the biomaterials are much more interact with our biological system. It will interface with the biological body. So bioactive means a material which are placed within our human body and interacts with the surrounding bone. So basically here I have write bones, but you can write also tissue or organ also. So here some like a soft tissue it can be. So those occurs through a time dependent kinetic modification of the surface. Okay. So like from surface it will be mineralized so that the bioactivity of the biomaterial taking place. So some these are basically a ion exchange reaction are taking place. Added with this definition, you can just keep in mind that it is the ion exchange reaction between the bioactive implant and surrounding biofilm. So what I told previously that it will mineralized from surface. So example of this kind of biomaterials is like carbonate apatite. Now come to the bioresorbable biomaterials. So bioresorbable biomaterials are the materials that upon placement with the human body start to dissolve or reabsorb. Means after few days of implant, this kind of biomaterials may be dissolved into the biofluid and the new tissue will form at that place. So slowly replaced by advancing tissue, what I said, such as bone. Commonly example of bioresorbable materials are tricalcium phosphate from metallic point of view or composite point of view, and polylactic or polyglycolic acid copolymer. So this is the copolymer thing. So this these kind of things are basically we have keep in mind. Okay. So this is the PLA PGA copolymer. So please keep in mind copolymer are the polymers where the two polymer are two polymer are bonded with different types of polymerization. So if PLA is the polymerization of degree M and this is the polymerization of degree N, so M and N polymer can be formed as a copolymer. So, so this is the basically the definition of what I mentioned here is based on these properties of the biomaterials. So next day we will discuss about the history, how the biomaterials comes into picture and how the evaluation of biomaterials taking place with year. So that's all for today. Thank you. Thank you for watching the video.